Hello and welcome to my talk about platelet ice under Arctic pack ice in winter. This is work that has been conducted during leg 2 of the Mosaic expedition in the last winter, and I want to thank all my long list of contributors to make this work happen. What is platelet ice or sub-ice platelet ice? Well, we are talking about decimeter scale ice disks that are growing and accumulating underneath sea ice. You can see them here in the picture on the right hand side. Some pictures of how platelet ice typically looks like from a review paper from Mario Hoppmann published this year. And one of the important things about platelet ice, or what we know about platelet ice so far, is that it is mostly associated with ice shelf interactions, and so seems to be often described as a feature that is limited to Antarctica. But what do we actually know about platelet ice in the Arctic? So there are only very few and quite some only indirect observations, and most of these observations come from seasons of spring, summer, or fall. And most of these descriptions describe some fragile ice formation due to meltwater percolation causing growth of platelet ice underneath the sea ice. However, there are hardly any observations during the winter underneath sea ice. There have been some observations, for example, during the Tara drift, but Mosaic was the first chance to really study this system in a complete winter season. So in the last winter, you have probably heard about the Mosaic drift. On the right side here, you see the drift track that Mosaic took from October to April. And during that leg, we were able to accomplish year-round ROV observations with under ice surveys up to twice per week. We also managed to repeat the same places under the ice flow in a weekly pattern. And what is also special about the Mosaic setup is that we have a distributed network of autonomous oceanographic observatories in a scale of 50 kilometers around the main drift site. To begin with, we didn't really expect that we would see any platelet ice, but when we put the ROV into the water in winter, starting in late December, we really started to dive into a maze of these amazing platelet crystals. And here you see a few pictures of how these crystals are growing on blocks of ridges, on anything that is deployed into the ocean, on all kind of different features, and also within some cavities. So there was clearly a platelet ice around during our time there, and we could document it for a long period of time. This shows a map of the mosaic flow. The color code is a normal ice thickness map. So here the green or the light blue and green areas indicate thicker ice, and the gray symbols symbolize where we found the most prominent platelet ice locations. First of all, I should say that we have seen platelet ice almost everywhere, also under level ice, and this map only shows where it was the most prominent. But even there, you see that also under the level ice and everywhere within the reach of our ROV, we explicitly observed platelet ice. In some cases, in conjunction with features like brinicles, but not always. And we were also able to take ice cores in several of these locations where we knew there was platelet ice growth going on, so we could then look into the crystal fabric. So the platelet ice typically grows from supercooled water. So here on the right side, you see some from the ROV, some salinity and temperature profiles. And the most important plot is here on the right side. That's the freezing point departure depending on the depth, and obviously in the top water column the freezing point only depends on the depth in the water column, and you see that at around 20 meters or so we crossed the freezing point, and the entire mixed layer kind of was in a super cool state. We also see that this degree of supercooling is strongest at the surface and linearly decreasing with depth. And this corresponds quite nicely with some of the observations of the platelet ice growth that we see along ropes and chains, which also have a wedge shape following this profile. So this supercooling was not just evident from some of the ROV CTD profiles, but this is data from the microstructure sound CTD probe from November to February. And you see that the entire water column was really supercooled relative to the surface freezing point. And this layer of supercooling even deepened over time. And we started to observe platelet ice once we had this very stable mixed layer of around 30 meters of supercooled water. So as I already said, it grows on everything that you put into the water, and some days we needed to park our ROV for one night in the water. And even during that short time, we can see how these crystals grow on certain surfaces. And here you also see quite nicely that it needs some crystallization nuclei to start growing. So you always see it growing around some edge features and not so much on homogeneous plastic surfaces. But for example, on ropes, you can nicely see them growing through the rope structure. Over the time, we observed various amounts of platelet ice. It was coming and going again. There was always some, but the intensity definitely changed. During that period, we also observed an average ice growth of 5 to 8 centimeters per week. So the ice was growing quite rapidly. So probably the platelet ice growth and the normal columnar ice growth were in some sort of competition. To investigate the temporal resolution in more detail, we can now make use of these autonomous observatories that we have in the larger vicinity in the distributed network around the central mosaic flow. And here you see temperature measurements taken at 10 meters depth from 7 of these oceanographic units in a larger area. And you can clearly see that also in these systems we have a clear signal of supercooling, and the intensity of these vertical lines, so whether they are dotted, dashed, or solid, indicates also how much platelet ice we observed with the ROV dives. And you see that we started observing platelet ice here once we had a very stable supercooled layer, which then with some events in the water column started varying. And once the temperatures rose again above or into close vicinity of the surface freezing point, then or the freezing point, then we stopped seeing platelet ice and there was no platelet ice anymore. Also in the beginning of the year, when the season, when the water was still very turbulent and there was a lot of things going on, there was no obvious platelet ice formation. So this data set shows us that we have this platelet ice formation due to consistently a supercooled mixed layer, and that this is a widespread feature in the Arctic, and it's not just a local curiosity of the mosaic site. So this seems to be happening much more widespread in the Arctic. So as I already said, we were able to take ice cores in several locations where we also observed the platelet ice growing into the ice. And here you see thin sections of 4 different sites of multi-year ice, first-year ice sites, and different sites with the horizontal and vertical thin sections. And at first glance, you don't really see any clear evidence of platelet ice as you would expect from when you look at Antarctic platelet ice. But if you look into detail, you find here and there the odd crystal that actually is platelet ice. So we know that the platelets are in there, but we can also see that they are very hard to detect here in these ice cores. So that might be one reason why it hasn't been really seen in the past sea ice texture analysis, because it's so easily overlooked. Well, one of the main questions is always, does this matter at all that we didn't know this. And well, the first thing is on the local energy and mass balance of sea ice, where this platelet ice probably doesn't have a big effect. Contrary to Antarctica, where platelet ice contributes significantly to the sea ice mass balance, here it doesn't, because here platelet ice is a local effect from local atmospheric cooling, and it's not generated by some supercooled water mass that is advected from somewhere else. But it has some other importance. For example, it is a significant process that helps the reconsolidation of pressure ridges, as you can see here in the right picture, when the platelets are starting to fill ridge cavities quite efficiently. And also, it changes significantly the habitat structure for ice-associated fauna, like you can see here on a camera picture, this little amphipod roaming around in this maze of ice crystals. In a summary, we can say that we have conducted the first comprehensive observations of wintertime subice platelet layers in the Arctic. There is substantial supercooling in the surface mixed layer, and this seems to be a widespread but yet mostly overlooked feature of winter sea ice growth. And if you want to know more details about that, I invite you to look at our publication in Geophysical Research Letters. And with that, I want to thank you very much for your attention and have a nice day.